Here is Emenso, and we are going to see a so-called world hardness easy geometry problem. And this question can be found in the website showing here. And if you're interested, you can go to the website to dig out some fun for yourself. Okay, let's look at the question itself. Here is a triangle. Within the triangle, there is two lines, that is DC and DE. And also there is a line called BE. With DE and BE, we have an angle theta showing on the graph. And this is the problem itself. We are going to find the value of this theta. Under the rules of the question, it is stated that we can only use simple geometry knowledge to solve this problem. Let's see what we can do. Now, because I want to use the bottom angles, so I draw a line called DF, which is parallel to BC, so that I can use the corresponding angles to bring this the bottom angles onto the angle that close to the theta. Now there is a little more knowledge within here. Now we can see that clearly the angles DAC, which is equal to angle DCA, which is equal to 20 degree, and so I can say AD equals DC side opposites equals angle, which is the properties of isosceles triangle. Now I construct the line so that DF parallels to BC. I just write it down in case you can read it again and again. And as I say, the reason why this line exists is I want to bring angles down the bottom to the triangle, which may close to theta. And for the process, you can see that AD is equals to AF because they have the same 80 degrees. And I can conclude that DC is equal to AF. Oh, let's see what's next. I want to construct one more line, that is BF. For doing that, I can show a pair of congruent triangles. As you can see, they have the common line BC. And I proved that before, this B is equal to FC, and we have 80 degrees angle between the two lines, or between the pairs of corresponding lines. They are the include angles. So I can prove that they are congruent by SAS. For doing that, I can say angle GBF is equal to 10 degree. And there's one more thing I want you to notice, that is, through the alternative angles, which is the properties of parallel lines, I can find out that angle D in here is 60. So is the angle F. And then by the angle sum of triangle, we know that angle L is also 60 degree. So my conclusion is, and triangle DBC is equilateral triangles. Just like what I put here. For next, I want to draw a line that is perpendicular to DF, which is AG. And then after I draw AG, you will find out that there is another pair of congruent triangles. And most importantly, we find out that the angle A is bisect into two smaller angles. They are both 10 degree. And in triangle AGB, AGB, we can see that angle A or GAD is 10 degree, and angle B or angle GBD is also 10 degree. And so I can conclude that AG is equal to GB. Now I extend AG a little bit to point H. And then it is easier for you to see a congruent triangles over there. And why they are congruent, I leave my proofs here for you. But the conclusion is very important. That is, GE is equal to GH. By the reason, corresponding sides are congruent triangles.